Hi everyone, I'm happy to be here with Darren,
our technical solution specialist here at SSI, and I'm excited to talk a lot about the R&D stuff that SSI is currently taking on. So kind of what's some of the most exciting projects you're working on right now, and what are you looking at?
So when it comes to R&D, the great thing about working at SSI is they look at it as an investment, right? To improve ourselves, the best thing to do is to do research and development. You want to improve yourself as a product. So we look at the industry as a whole, and a lot of our clientele are in the defense area. And what benefits us the most with that is the defense industry as a whole and the government as a whole likes to invest in new technology, makes shipbuilding easier, makes shipbuilding more affordable for them as clients. So the U.S. government itself has taken the initiative on itself to start a program called National Shipbuilding Research Program. Within that program, every year the U.S. Navy funds this research and development with research announcement projects. ShipConstructor has taken it upon itself to participate in that from the get-go. Even in our infancy, our president, Pat Roberts, when he was down at the shipyard, that was part of his role, was on the R&D side of things, participate in R&D development at the shipyard. Well, they had the tool ShipConstructor in its infancy at the time, and they took it upon themselves to participate in these projects. So you would have these things called research announcements, where the industry came together and they proposed projects together with either core yards or other industry partners and core yards within the NSRP project or program environment, and you propose this as a whole and it's voted on. So if it's something that the industry as a whole wants to innovate with, they will vote on it together and take that project on and participate in it. And some of the stuff that we're doing and we've completed here recently is one, it was a shipbuilding design course, modern shipbuilding design course. Way back in 2008, ShipConstructor and some of the industry partners had done an initial design course for marine design. So how do I get my people at my shipyard to understand modern shipbuilding and modern ship design, and let's put it in an easy course form for them to learn shipbuilding or design within the family of products. Maybe it's AutoCAD itself, maybe it's ShipConstructor itself, maybe it's process at their yard. So they wrote a design course way back then. Well, here within the last year, ShipConstructor participated in one called Modern Shipbuilding Design Course 3, in which we proposed to update that course material, which was way back in 2008. It was outdated. It was using an older version of ShipConstructor, pre-database version of ShipConstructor. So the team up in Victoria, our team up in Victoria, kind of jumped in 2 feet with us and said, let's look at that old material, let's see what we can do to update it, and let's bring it to the forefront, right? Bring it forward, make it more modern, make it with the latest version of our ShipConstructor tool set, make it with our new PSV model that we use as our tool set, and how does that look to an industry person or a shipyard or design agent? How do I now use that tool to train up my staff? That's one of them. Another one is, it's called automated detail planning. It's kind of in its infancy of the project. It's just kicked off this not long. It's taking the metadata from our models and feeding a planning system. So on the front end, shipyards tend to have a lot of hours spent planning out and detailing out how are they going to attack this modular system, and how am I going to put it through my system in my yard, how I'm going to put this together. And that detail planning tool, in conjunction with ShipConstructor, is one of those things that we do. Now, one of the legacy things that we did before, and I think we talked about it earlier when we were at this other thing, is a legacy project that we participated in when I first started with ShipConstructor, and it was called computer-aided robotic welding. And I really took initiative with that one because I was on the initial welding side of ShipConstructor, and we participated with one of our clients, Bollinger Shipyard, I guess I can say their name in here. They wanted to innovate automation at their facility, and their facility, they wanted to take some of their really highly skilled welders out of the mundane area of doing panel line work and move them to their waterfront facilities. So they wanted to take ShipConstructor's weld module, feed that information to a robotic welder, and weld out systems that would be mundane for their really skilled laborers, and put those laborers where they could really benefit the shipyard. And that's what we did with them. And it was a good 2-year project where we took our ShipConstructor module and fed all of that metadata, not only the welds, but the weld locations, and fed that to a robot system where a guy just matched it up to a process, and he hit the button and we watched this thing weld it, weld the information out. It was really great. It's something really cool to be a part of, right? So,
how do those R&D developments, how does the NSRP work translate into the solution, into other shipyards or the commercial world? How does that work?
Yeah, so speaking on that through another project that we've worked through where it's had multiple iterations is one called Lift Ship, where you have an industry need. Whereas when I worked at the shipyard, small shipyard in Louisiana, you had to do weight studies because you have to move these huge blocks of your vessels around the yard. And people don't think about that. They think, okay, this is a static build, you're building things in one spot. Well, sometimes you have a small yard, space is limited, you have to build things here or there, and you have to move that large piece of equipment or a large section of the vessel from here to there. And this project that we teamed up with was called Lift Ship. And Lift Ship was basically, the initial phase was, how do I get all of my weight information for a particular assembly into one location so I can do weight studies or weight reports that I can feed to production drawings that say, pick it up in these locations, add lifting lugs at these locations on this particular piece of assembly, so that my crane can physically pick that thing up and move it to a location within the vessel, whether it's all launchways or maybe it's another fabrication bay or anything like that. And that project in and of itself, R&D wise, had legs, right? So we got to the finish line of that first iteration, and the industry itself said, we still see a need. We want more. We want more from this thing. So it moved from just a weight study to a thing called a dynamic lift and turn, where you're building maybe a module that's upside down. You're building it upside down for a reason. Typically, it's you're wanting the weight of plate that you're putting on this particular assembly to help you put it together. It's easier to lay plate on something and have the weight help you form it into place than it would be if you had it right side up and had to pull things up to put them into place. So that dynamic lift is, I'm taking that piece, I'm lifting it up physically, either with cranes or overhead crane or some kind of physical tool, and turning it. And what is the dynamics that are going to happen to that piece of equipment when it goes in that inverted position, when I move it? That is a huge piece, a mass of steel and equipment, and how is it going to react in an environment that you don't intend or you don't plan for? Anybody that's picked any kind of heavy object up, especially something that's an odd shape or anything like that, when you pick it up, it reacts to how you're picking it up. So we took the metadata from ShipConstructor and fed it to 2 FEA tools, one being FEMAP and the other one being HyperWorks, and fed the metadata across to it for them to go through iterations of analysis of these assemblies in different locations and how that huge mass of steel and equipment was going to react once you moved it into that position. Once we got to the end of this, we had a working model to be able to put iterations out, right? From the ShipConstructor model, we could feed those 2 FEA tools over and over and over again. Instead of a dumb model, that metadata that's associated with steel and equipment that is in the ShipConstructor SQL database, all of that equipment, all of that steel knows what it is. It knows where it is in space within the ship model. Now the FEA tool knows what it is in space, and how it's going to react now because of the analysis tool. The industry still sees a need for more. So we partnered again with NSRP, and we've had a 3rd iteration called Lift Ship 3. where now we're taking that same dynamic lift and turn, and we're saying, okay, now that we get to the end port of the analysis and said, okay, now I'm turning this portion over and there's a reaction. Okay, an unforeseen reaction just based on the typical database information, the typical model information. There's a deficiency once I turn it over. The steel's going to react differently if I don't put strongbacks, or if I don't shore it up with some kind of piece of equipment, stiffener, some kind of stiffening to it. What happens is you don't want that in your core model. You don't want that to be part of your ship that you deliver, because it's not actually going to be part of your ship that's delivered. You're only shoring up that lift and that turn. So the third iteration of lift ship says, okay, here's a list of items from my stock catalog that are available in my yard. And when I do the analysis, I can pick from those and feed those back to my assembly drawing and actually show them in my weight study drawing that production can see. Now they can go to their stocks and say, hey, I got one of those, place it here, shore up the lift and turn, and then execute the lift and turn. And it's really exciting portion of that, and that's what's an ongoing R&D project now.
And that's another way to keep the digital twin as it's delivered. Absolutely. Exactly as it's...
Absolutely. So the other portion, and it's kind of like a byproduct of that particular project, because like I said, the industry looks at it, they see that need, they say, okay, I want more, I want more. And one of them is, we had a client come to us after the second phase, which was Lift Ship 2, and they said, can I take any assembly from my build strategy, from my tree of assemblies, and can I export that? Does it have to be a full unit? And we were like, of course not. You can go down to the part level, and we could say, let's export a part level to do an analysis on. Maybe you got a section modulus or an analysis you want to do on one particular frame. It's just an assembly within the model, so we export that and you can run your analysis that way. The other one was, we had a client come to us and say they were going to install a high RPM pump on an initial designed foundation, and they wanted to run an FEA analysis that if they kicked on this pump, how would the foundation react to those dynamics. And the only way to do that was to run it in an FEA sim. So we said, well, absolutely, we'll just show you the process to get that foundation out, and you can use the FEA tool to run your analysis. And then if there's any deficiencies with the third iteration, of course, of the project, now you can make recommendations on design changes. Maybe it's plating that's too small, you might need a thicker plate, things like that. So.
You mentioned working with partners like Altair for HyperWorks, for example, and obviously you're working with shipyards as part of these R&D projects. How do you work with them? Because often there's the stereotype, at least, that a vendor and a shipyard, they're going to butt heads, they're kind of at odds with each other.
Shipbuilding as a whole, and in this industry, it's very small, right? We think of shipbuilding, it's a worldwide thing, and there's huge amounts of people and things. But it's a family in and of itself, and we all kind of in the same swim lanes of things. So when you do analysis, say I worked at the shipyard and we would farm out our FEA tool. Well, we knew the guys at the FEA software because you typically had that software with you. So it's something you're enhancing the toolbox that you already use, right? So if a shipyard says, hey, I use HyperWorks or I use FEMAP for my FEA analysis, well then let's go to those guys. Let's partner with those guys. So we look to those industries as well. If it's somebody that we already know, or maybe if it's somebody we don't know, we go and look and see what they do and see if we're a good connection with them, and then we reach out to them and partner with them. That's where our SDN network comes from as well. So, ShipConstructor's developer network kind of has morphed into that. So on our PLM side, it was the Aris. Aris is our tool for our PLM. They were an SDN member first, and that's how our partnerships develop on that sense. So they all swim in the same pool as us, so they talk to the shipyards, and then they'll talk to us. So they'll talk to the design tools as well.
Yeah, thanks so much, Darren. Really appreciate getting your perspective,
Absolutely.
getting that update on what's going on. And
absolutely,
yeah,
great talking with you, Greg.